dear students, in this video, we are going to solve a very interesting question based on lens maker's formula. This problem helps us to understand how the focal length of a convex lens changes when it's placed in air and water. Okay, so understand the question first, which is the radii of the curvature of two surfaces of a convex lens is zero point 0.2 meter and 0.22 meter. Then they are asking find the focal length of the lens if Ri of the material is 1.5. Also find the change in focal length if it's immersed in water. Okay, which is water of the Ri is 1.33. Okay, so I already drawn on lens here. So see radius of curvature ಕೊಟ್ಟಿದ್ದಾರೆ which is so one side ಅಲ್ಲಿ this radius will be 0.2 and another surface in ಕೊಟ್ಟಿದ್ದಾರೆ which radius is 0.22 meter. Okay, so focal length find out ಮಾಡಕ್ಕೆ ಕೇಳಿದ್ದಾರೆ. So from the lens maker's formula we know that 1 by f is equal to n to 1 minus 1 into 1 by r1 minus 1 by r2. So first given data ಬರ್ಕೊಳ್ಳೋಣ. Okay, so r1 ಕೊಟ್ಟಿದ್ದಾರೆ which is 0.2 meter and r2 is 0.22 meter. See, if ray of light is in this direction, then r1 will be taken as positive and another r2 will be taken as negative, right? Refractive index is given, that is n is equal to 1.5. Now apply in this equation. See, another one is air medium, so n2 by n1, that means n2 is 1.5 here and n1 is 1. Okay, so we can directly consider this equation as n minus 1 into 1 by r1 minus 1 by r2. Okay, so now apply the values, which is 1.5 minus 1 into 1 divided by 0.2 minus 1 divided by minus 0.22. So that will be, when you solve this will be 0.5 into 5 plus 4.55, which is equal to 0.5 into 9.55 equal to 4.78. So this is the value of focal length when lens in air contact. Okay, when lens in air contact. So when you reciprocal this value, which is equal to fa, 1 divided by 4.78, which is equal to 0.21. So now they are giving that find the change in focal length if it is immersed in water. That means, see, in the container they immersed this convex lens. Now they are asking focal length of this. Now they are asking change in focal length of this condition. Okay, so in that case you have to consider 1 by f. I will take this focal length as fw, which is equal to n2 1 minus 1 1 divided by r1 minus 1 divided by r2. See, n2 divided by n1 minus 1, which is equal into 1 by r1 minus 1 by r2. Okay, so here, see, light rays moving in this direction, that means it will this will be n1 and this is n2. Okay, so in that case 1.5 minus Ri of refractive index value of water is 1.33 minus 1 into 1 divided by 0.2 minus 1 divided by minus 0.22. Okay, When you simplify these values, that will be 1.1278 minus 1 into, see, we have find out this earlier, which gives 9.55, 9.55, which is equal to 0.1278 into 9.55, which is equal to 1.22. So this is the focal length when lens is immersed in water. Okay, so when you reciprocal this value, which gives focal length 1 divided by 1.22, which is equal to 0.82 meter. So now we have two values. One is focal length in air condition and focal length with water. Okay, we have to find out change in focal length. For that, change in focal length equal to water minus air, which is 0.82 minus 0.21, which is equal to 0.61 meter.